Okay. Now, finding hotspots to reduce risk and improve productivity. What are hotspots? What is a hotspot? So I would define a hotspot as a file that is often changed and also complex. And we know from research pretty well that those are the places where bugs are frequently introduced. So this is the things that introduce those regression bugs. If it's frequently changed, people are standing on each other's foot trying to do changes on that file. And that is usually an area where problems are introduced or a good root cause for many of the problems we have in day-to-day operations. So how would we define complex? And I actually found this method by reading a book called Your Code is a Crime Scene from 2013 from Adam Thornhill, I think. Highly recommend. I read this on a plane when I was flying between Europe and the United States, and it's a really interesting read. And I learned a lot of things from that book. Adam started to use file length as an indicator of complexity. You could do that, and if you have a 3,000 lines long file, chances are that it's complex too. But there are also other metrics. You could use something based on cyclomatic complexity. Cyclomatic complexity is a metric that basically tells you how many paths you have to go through a method, and also is a floor for the number of test cases you would need for 100% test coverage. And of course, since we're talking on class and file level, here we need to average that up on the method level. And what you usually do is to use a weighted average for the methods. And as a weight, you can use the number of statements in the method. So long methods have a bigger weight, larger weight than short methods. Or you can use average indentation, also based on max indentation per method. That's also a thing that was recommended by the author and also works pretty well. And the next question, how do you measure change frequency? For that, you need to access the data in your version control system. And your version control system actually has a treasure of data that are very interesting and how to look at your project. So a couple metrics we can derive from the version control system. How often was a file changed in the last X days? Or how many lines were changed in the last X days? Then you can compute the code churn rate, which is basically lines changed divided by lines of code, and how many different people worked on a file in the last X days. All interesting data, and you can all extract them from your version control system. This is a book I was talking about. Definitely a recommendation. Now let's talk about how to find hotspots. And for that, we jump into Sonograph now. Where is it? Right here. So I opened an open source project here called Apache Cassandra. It's a Java project, but that also works for C#, Python, and C++. So in this case, on the left side, you see navigation view where you see the physical structure of your project. In the namespace view, we see basically the logical structure, which just contains namespaces, or in Java they're called packages, and the structure in there. Here you see some metrics, and in this case, we installed a baseline, and that's going to be the topic for tomorrow's webinar, where we talk about the toxicity of structural erosion. We can see that certain metrics are really not looking very good. Maintainability level is at 9.7% of a possible 100%. That's very low. System average component dependency increased from version 3 to the current version of Apache Cassandra by 510 points. Means every Java file I'm looking at here directly or indirectly influences 1426 other Java files. Now, when it comes to metrics in general, this is just an overview that looks at system level metrics here. And we're just working on that dashboard to make it a little nicer, but it already contains a lot of interesting information. For example, how many lines did we add since version 3? Quite a bit. And then we have a metrics view where we can look at the metrics in more detail. So the metrics view, the most important thing is to understand that level here. We have system level, module level, package level, component level, and source file level. Component and source file in Java is the same thing. We make a differentiation between the two because in C++ it's actually different. In C++, a component is a combination of a header and a source file, while in C# and Java, the component and source file is identical. And here we have all the metrics: code churn 30 days, so how many changes, how many lines were changed in the last 30 days. And the winner is async future with 820 lines changed. We can also compute the code churn rate. And yeah, async future has been rewritten basically 5 times over. 539% code churn rate, that's pretty high. So that file was rewritten many times in just the last 30 days. Now we can also look how many authors does a file have, and in Apache Cassandra, a couple that many people are work on. And there's also quite a number of knowledge monopoles here where only one person worked on that file in the last, let's see, look at 365 days, that's more interesting. And you see it's a pretty active open source project. Storage Service is the winner with 26 different authors in the last year. Let's see if we go to the bottom of that. But we also still have many areas where just one guy is working on it. And Benedict Elliott Smith, you see that down here. There's one guy who works on that particular file, obviously. He seems to be one of the core developers of Apache Cassandra. Now let's look at the visualization, because this metric view is very nice and you can combine things. For example, you could say a number of authors and say, let's say, combine lines of code and get something like a little spreadsheet here where you can see the different metrics lined up next to each other. Okay, now, but it would be nicer to have a better representation of that, and that's for that purpose we created the tree maps. And I prepared different tree maps for Apache Cassandra, for example, code churn and complexity. Let's look at this one. That's now a 3D visualization of the code base. Each of those buildings, I call it a software city view, so the little blocks, I call them buildings. Each building is a source file. The footprint of the building is the size of the source file in lines of code. The height of the building is its complexity. And the color is the change frequency. In this case, we say code churn. So how much was changed in it. And we see a red tall building behind here. It means it's complex code. It's a relatively one of the larger files. If you look at the footprint, not as large as this one. Those two, by the way, are generated. This is a SQL parser that comes with Apache Cassandra. If I look at this, this would be the database descriptor. And if I hover over it with a mouse, I can also see the metrics. So we have 2,808 lines of code. We have 281 lines changed in the last 30 days. And we have an average complexity of 26.54. So that would basically, that could qualify as a hotspot. And we have different ways to look at it. I prepared different more tree maps, and we can put them next. And here we used code churn 30 and indentation complexity. So we used indentation instead of average cyclomatic complexity. That looks a little bit different. And I can actually put those two next to each other if I want to. Something like that. You can see them both. See, average complexity seems to be pretty high. Indentation is not that big in that file. Okay, now we can look at the source code and make a judgment call. Is it bad or not? Do we need to do something about this? And this is basically the file. A couple of issues here. It's part in the cycle group. We're going to talk about all this topic about cyclical dependencies and problems like this a little bit later. But let's look at the code and see if you can find anything that triggers that complexity thing. And yeah, this is a cyclomatic complexity of 96. That is pretty much the method that messed up that value. It's one big method that is 271 statements long. And we have two threshold violations because in our quality model, we defined the maximum length of a method to be 100 statements, and we allowed cyclomatic complexity between 0 and 15. So it's definitely outside of that range. And if we go down here, we see it's a lot of if statements that basically do something here. It's a very, 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 very long method. So now it would be a judgment call. What are we going to do about it? And I'm going to talk about this a little later. Let's do a different other tree maps I prepared. For example, we have issue count and complexity. So in this case, we use, I just have to double check, the size source is lines of code, the color source is the number of issues, and the hate source is average complexity again. So again, this is, so the things that are more red are basically have more issues in them. And if you click on them, you can see what's happening here. Down here in the properties, you can actually even see how many people worked on the code. Yeah? These are authors in the last 30 days, 90 days, 365 days. And you get the issues that are in there. It's part of a big cycle group. And again, the cycle group topic will be part of our discussion tomorrow. Okay, now I'm going to show you how you can create your own tree maps. Shouldn't be too difficult. I just say new tree map. Call it demo. Now we have different things what we can use. As size source, I usually recommend lines of code. You can also use source element count, which would be a little bit more fair because sometimes the lines of code is influenced strongly by the way you place your curly braces. And if you want to have a more neutral map, we can use source element count. Then we have the color source. And there are different metric available on this level here. So we can also change it to component up here. And then we get a different set of metrics. For example, I want to know which file has the most incoming dependencies. That would be interesting, right? Number of incoming dependencies is a color source. And let's say average complexity is a hate source. Huh? And that will create a new tree map for me. And again, here the red and the colored buildings are the ones that have the most incoming dependencies. That's also an interesting criteria to see where hotspots are, because things that have a lot of incoming dependencies and are changed frequently might be a problem. Yeah, because those changes affect a lot of other code. We can probably even define a better tree map. Let's call it demo 2. Where we can go on the component level, lines of code, and then we look at the color source again, the changes, let's say number of changes. Where is it? Code terminate. File changes here, that's it. Let's say in the last 90 days. And the hate source is number of incoming dependencies. And again, it's always this little block on the top right. So that's the thing we could look at. So that should give you an idea. I think it's a very good thing to look at the code base when you think about refactorings. Where would you do refactorings? And you probably don't want to do too many refactorings in areas of the code that are hardly ever changed, because how they say, never touch a running system. But if you have something which is changed frequently and always shows up in these tree maps as something that is colored, you might have a look at it and at least consider if refactoring is necessary. Let's go back to my slides here. So what are we going to do about those hotspots? It's always a judgment call, that is clear, because not every hotspot is really something you should refactor, but you definitely should consider refactoring if the file is changed frequently, involved in bug fixes, if code is hard to read and understand, and or if responsibilities are not clearly defined. Those are candidates which are probably good for refactorings. Now let's talk a little bit about what we do. As you already know, we offer that beautiful product called SonarGraph, and you can of course try it for free. And then we also offer services. So for many companies, implementing such a architecture and quality enforcement thing in their tool chain is quite a bit of work, and most people don't have the time to do that. So we can completely make a turnkey solution for you where we implement that in your organization, integrate it in your build, do all the automation that's necessary. We also offer software assessment services. So if you have a project which is in doubt, we can do an assessment. We can do it very cheaply because we have that beautiful tool that allows us to do a complete thorough software assessment in 2 to 3 days. We offer developer training. That is also interesting because many developers don't know much about software architecture and especially the meaning of cyclical dependencies, anything like this. So if you want to train a team to produce better results, we have 1 day and 2 day trainings for that, and they're pretty effective to dramatically improve the quality of the code coming out of your development organization. And then we help you with all kinds of modernization projects. SonarGraph is the best tool available on the market right now for software modernization. So if that's the thing you want to do, we can definitely help with that. What would be potential next steps? So if you're interested to learn more, I can arrange an in-depth demo with you, and we can even run it on your code if you want. So you can learn something about your project. Of course, you can get a free evaluation of SonarGraph, so you can test it completely for free. We even have a free product called SonarGraph Explorer, which is completely free for commercial use, but contains just a subset of the features of SonarGraph. But those subsets are interesting. It's dependency visualization and metric gathering. And then, of course, we could discuss your potential service needs.